Today on geometry, we're going to have a conversation about angles and parallel lines. You know, without geometry, life is pointless. Get it? Pointless. So the first concept we're going to discuss is the corresponding angles postulate. And why do we use a postulate here? Well, this is because we don't need to prove this. This is observed through conjecture, right? Observed and induced. And so basically, we're going to accept what this postulate says without proof. Now, you're going to notice on all of these theorems and postulates we're going to talk about, we're stating some truths here, but they're all going to start off with two parallel lines that are cut by a transversal. So here is our transversal, and our two lines here are parallel. So we're going to mark that there, right? So each pair of corresponding angles is congruent. So what does that mean? Well, that means that this angle here, upper left, and this upper left angle are going to be congruent. And this upper right angle to this upper right angle are also going to be congruent. And we can kind of work through this concept, but we're going to say here that angle 7 is an angle 5 because this is lower right and this is lower right, so those would be congruent. And then we would say angle 8 and angle 6 are congruent because those are lower left and they're corresponding. So when we take a look at this, what we have looked at due to, so we only need really one pair of corresponding angles. The rest of this is done through supplemental, like linear pair and or vertical angles, okay? So our congruent statement is going to look something like this. With these four congruences that we can list. So those are the congruence statements. Okay. Now we have a theorem, right? We have the alternate interior angles theorem. We have this theorem, right? Theorem, alternate interior angles. So if two parallel lines, again, are cut by a transversal, then each pair of alternate interior angles is congruent. Well, one of the things we can look at with this is to say, okay, I know that this angle here that I'm going to call angle 5, right? And that angle, actually, let's change the color on that for what we're doing. So we have angle 5 here. Well, angle 5 is corresponding to angle 2. But angle 5 is also vertical with angle 4. So because angle 5 and angle 4 are vertical, they're congruent. Since 4 is congruent to 5 and 5 is congruent to 2, therefore 4 is congruent to 2. And we've just proven this theorem that each pair of alternate interior angles is congruent. So our congruence statement would be angle 1 is congruent to angle 3, angle 2 is congruent to angle 4. Okay, now we have another theorem. So this theorem is consecutive interior angles theorem. So if you recall consecutive interior angles, those would be two angles that are on the same side of the transversal, right? So what we see here is that angles, so we want to say, okay, is angle 1 congruent, supplemental, right, to angle 2? Well, again, we start with this being cut by a transversal. So how do we prove this? Well, we know from what we just discussed that angle 4 is congruent to angle 2, right? So angle 4 is congruent to angle 2. I can see that we have a linear pair here with these two angles right here. And since they're a linear pair, we know that angle 1 plus angle 4 equals 180. Well, because 4 and 2 are equal, I can take 4 out and I can put 2 in, and I can say now angle 1 plus angle 2 is equal to 180. So our statement of truth coming out of this, or fact, we can say that angle 1 and angle 2 are supplementary, and also angle 3 and angle 4 are supplementary. That means they add up to 180. Okay, next theorem, and that is alternate exterior angles theorem. Two parallel lines are cut by a transversal. Again, we keep starting with the same thing. Then each pair of alternate exterior angles is congruent. All right, well, we know that, let's put an angle here. We'll just call this angle 1. So angle 5 is congruent to angle 1 by corresponding angles postulate. By vertical angles, angle 1 and angle 7 are congruent. So now I can look at this and say, well, since angle 1 is congruent to angle 5 and angle 1 is congruent to angle 7, then I can say that, well, okay, angle 1's congruent to 5, angle 1's congruent to 7, then angle 5 is congruent to angle 7 by substitution. So we're going to use this and we're going to say, hey, those are our congruence statements. Angle 5 is congruent to angle 7. Angle 6 is congruent to angle 8. All right, perpendicular transversal theorem. In a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. Well, so if I'm told that line T is perpendicular to line A, I know that this angle is a right angle, right? Well, since corresponding angles are congruent, right, both of these lines are parallel, then this angle down here must also be a right angle. And since this is a right angle, then T is perpendicular to B. So if a line A is parallel to line B, then line A is perpendicular to line T, then line B is perpendicular to line T as well. All right. Now the key for what you need to do is you need to be able to use these theorems and postulates to solve problems. Now the key that I find very important to solving problems is to mark up the diagram. Either redraw the diagram in your notes or on the worksheet and use the diagram in the worksheet and mark it up. So the measure of angle 5 is 72. So I'm going to write 72 right down here so that I can see it. Well, what's the measure of angle 4? Well, I can see here that angle 5 and angle 4 are corresponding angles. So the measure of angle 4 is also going to be 72, and that's going to be because of the corresponding angles postulate. Now, the next angle they want me to look at is angle 2. Well, angle 5 is on the left side of the transversal. Angle 2 is on the right side of the transversal, and they're both on the exterior. So that means they're congruent also. So the measure of angle 2 is equal to 72, and this is by alternate exterior angles theorem. All right, you guys take a moment and solve for these angles based upon the given information. Okay, so let's mark up the diagram. Angle 8 is 105. So we're looking for angle 1, angle 2, and angle 3. Well, angle 1 is corresponding to angle 8. So we would say measure of angle 1 is equal to 105. And that's corresponding angles theorem. Postulate, not theorem. Postulate. Well, angle 1 and angle 2 are supplemental. So it means they have to add up to 180. So 180 minus 105 is 75. So measure of angle 2, that's going to be derived, right? And that's going to be by linear pair, right? A definition of a linear pair, or just we could say it's because they're a linear pair. They have to add up to 180. The measure of angle 3 is equal to 105. And we could say it's because of vertical angles, but because we have these new theorems, we're going to say that's by the alternate interior angle theorem. All right. Now we've got problems of a different stripe, which is we're given some angle measurements, but then we're given an expression. Measure of angle 4 is equal to 2x minus 17. We're going to solve for x. So go ahead and let's mark up the diagram. This is going to be 85 degrees right here for angle 1. Angle 4 is equal to 2x minus 17 degrees. Well, I know that if angle 1 is 85, angle 7 is 85. And the relationship between angle 7 and angle 4 is that they're supplementary, they're a linear pair. So I'm going to set it up as this: 2x minus 17 plus 85 equals 180. So negative 17 plus 85 is 68. So I get 2x plus 68 equals 180. So I'm going to subtract 68 from each side of this equation. And I end up with 2x equals 112. And then I just divide each side by 2 using my calculator, and I get x is equal to 56. Okay. Now, in this question, we're going to come through here, and we're going to mark up our diagram again. So measure of angle 3 is 4y plus 30, and I like to put it in parentheses with the degree marking, so I know what I'm looking at. The measure of angle 7 is equal to 7y plus 6. Well, these two angles are alternate interior angles, so they're going to be equal. So that tells me that I can set up my equation as 7y plus 6 equals 4y plus 30. Subtract 4y from each side, and I get 3y plus 6 equals 30. Subtract 6 from each side, I get 3y is equal to 24. Divide each side by 3. Y is equal to 8. Okay. All right, so if you haven't noticed yet, there's two things you're going to be seeing with all these problems. All right. Either the two angles are equal, or they are supplemental. Okay, that they add up to 180. All right, you do this one, go to work. Okay, so let's look at what we know. We have the measure of angle 2, right? So we're going to be right here, 4x plus 7. And the measure of angle 7, which is 5x minus 13. So these two angles are alternate exterior, right? So because they're alternate exterior, they're going to be equal. So I'm going to set up an equation of 5x minus 13 equals 4x plus 7. Subtract 4x from each side, and I've got x minus 13 equals 7. Add 13 each side, x is equal to 20. All right, why don't you work on this one now, and let's see what you get. Okay, so now we're working with angle 3 and angle 5. So angle 3 is 3y minus 2 degrees. Angle 5, we'll put this up here, that is 68 degrees. Okay, so these two angles are consecutive interior. They're on the same side of the transversal in the interior, which means they're going to add up to 180 degrees. So I'm going to take and set up my equation. 3y minus 2 plus 68 equals 180. So minus 2 plus 68 is 66. All right, so let's subtract 66 from each side of this equation, and I get 3y is equal to 114, I believe, right? Yep, 114. So now we take out our calculator and we divide 114 by 3, and we've got 38. Parallel lines have so much in common. It's so sad they're never going to meet.